This is lesson 27, and in lesson 27 there's two topics that eventually we're going to talk about. And the first one is called the distributive property, part 2. And this is called part 2 because as you look at the example that I have written in the blue, we've already talked about the distributive property a little bit. And if you look at this, when we've used the distributive property before, we've said whatever's in front of the parentheses we distribute. Well, this problem's written a little differently because the part that's outside the parentheses, which in this case is xy, it's behind the parentheses. But I can write this so that I have xy in the front times the 3a minus 5p. Now I can distribute. And remember, when you distribute, you take this times the first term and then times the second term. So I have xy times 3a minus xy times 5p. Now I simplify it and I do my multiplication. So this is all multiplication. I put the number in front and then I have x, y, a, because x times y times a is x, y, a. Now it doesn't matter the order that you write the letters. I could have 3 y, a, x, minus, and then 5, put the number in front, times x, y, p. And I'm done because these two terms, the 3xya and the 5xyp, are unlike terms. I can't add or subtract them. Other thing before we get into this part 2 of the distributive property, there's two rules you got to remember. Now, what happens when you multiply powers? What do you do with the exponents? Well, you take the base or the common big number or letter, and then what do you do with the exponents? Well, you add them. 2 plus 4 is 6. So what this simplifies to is a to the 6. And that should make sense because a squared means a times a times, what's a to the 4th mean? 4 of them, right? And you have 6 of them, or in other words, a to the 6. So when you multiply powers, you add the exponents. Now, what's the difference with this example? Here we're adding. We've got two terms and we're trying to add them. Now, are these two terms like terms? Are they are my letters to the same exponent? And the answer is yes, because both these are to the a cubed power. So I can combine them because they're like terms. So I have 2 of the a cubes plus 4 more of them. I have 6 of those a cubes. And notice I did nothing with the exponents. So notice the difference between when you're adding and subtracting like terms compared to multiplying exponents or powers. All right, let's take a look at example 1. Now, example 1 is where we're using the distributive property, but it's just a little bit more complicated. And that's the difference with what we've talked about before with the distributive property. So whatever is in front, I'm going to distribute. So I'm going to take that times this, and then I'm going to take it times this. So you have x, y squared times the y squared p minus, because of the minus sign, and then x, y squared times p. Now I'm going to simplify this. So I'm going to do my multiplication. And let's see. In the first part, okay, I've got an x, right? Now what's y squared times y squared? This part right here. Well, you add the exponents. So that's y to the 4th. And then p. Minus. Now on the part right here, really there's nothing I can combine. So I just have an x, y squared, p. Now are these two terms like terms? Is this the same thing as this? Are they, not only do I have the same letters, but are they to the same exponents? And the answer is no. So this is your final answer. I've used the distributive property to simplify this. All right, example 2. Whatever's outside the parentheses, I'm going to distribute. So I'm going to rewrite this. I'm going to put the 2xy in front, like this. Now I'm going to distribute. So I'm going to take this times that, and finally times that. So I have 2xy times the xy minus the 2xy times the x. Now simplify. So do my multiplying here and here. Alright, so in the first part that I underlined in red, let's see, I have the 2 in front. Now remember, this is x to the first and this is x to the first. And this is all multiplication. So I'm going to just rewrite this. So really I could have rewrote this as 2x to the first times x to the first times y to the first times y to the first. Because the order that you multiply doesn't make a difference. I can switch that around. But what is x to the first times x to the first? Well, add the exponents. That's x squared. And what's y to the first times y to the first? Y squared. Minus 2. Now what's x to the first times x to the first? X squared. And then I have a y. Or I could write that as 2y x squared. Now, can I combine these? The answer is no, because this one is 2x squared y squared, whereas this one is 2x squared y. I have the same letters, but they're not to the same exponents. All right, final example, example 3. Okay, let's distribute the 3x p cubed. So I have 3x p cubed times the p to the fifth minus 3x p cubed times x squared p to the eighth. Now do my multiplying. So I have 3x. Now what's p cubed times p to the fifth? Multiply those powers by adding the exponents. That's p to the eighth. Minus. Now over on the right one, I can actually combine my x's. Remember, this is x to the first, so let's do that. I'm going to write my number first. So what's x to the first times x squared? That's x cubed. Now combine your p's. What's p cubed times p to the eighth? Answer, p to the 11th. Now, is this term like term to this one? Answer is no, because I don't have the same letters to the same exponents. So, your final answer is this. So, this is a little bit more on the distributive property. It's just a little bit more involved because you're actually having to use the rule for multiplying exponents, which is you add the exponents. And that's how it's different from what we've talked about with the distributive property before.